Hello children, warmly welcome to Gurugedara educational program. As usual, today also I am going to teach you another important lesson in grade 6 science syllabus. I am sure you can remember the previous programs that you observe. Right, in previous lessons I told you electricity for a comfortable life. Here we studied about how can we use electricity to make our day-to-day task easier. In the second program, you watched how to prepare circuits and what are the symbols that we used for different electronic appliances and also the users of those electronic appliances. Today, I am going to continue the lesson from the place where we stopped, and that we are going to learn what are electronic devices. Right. Unit 8, Electricity for a Comfortable Life. The third lesson. 8.5, Electronic Appliances. Before starting the lesson, I am going to ask you a question, my dear children. Have you ever seen the inner part of a television or the interior parts of a radio or a laptop or a computer? Right. This shows you the interior structure of a television. Right. Here we use various types of electronic devices. What are the devices that we use in those computers, televisions and radios? Right. Today we are going to learn those things. Right. We use diodes, light emitting diodes. In short form we call this as LED. Light emitting diodes, LED. And also we use resistors. Not only resistors, we use light dependent resistors. What does that mean? Light dependent resistors. In short form we call LDR. I am sure you all are very happy to study these components. Right. Diode. Have you ever seen a diode? Yes, I showed you in the previous program also. Today also I am going to show you a diode. This is a diode. It's very small electronic device. As you can see in the board, the diode consists of two terminals, positive terminal and negative terminal. The second picture shows you the symbol of a diode. Positive terminal, negative terminal. The arrowhead is pointed towards the negative terminal. Right. Shall we do a simple activity to understand the function of the diode and how does it behave? Right. First of all, I am going to show you this simple activity. I am going to connect a battery, bulb and a diode using these connecting wires. As you can see, the bulb is glowing. The bulb is glowing. Why is that? Current passes through the circuit through the diode. Now I am going to change the terminals of the diode. In this instance, I have connected the positive terminal of the diode to the positive side of the battery and negative terminal of the diode to the negative side of the battery. Now you can see very carefully, I am going to change the terminals of the diode. I change. Can you see the difference? What's the difference? When changing the terminals of the diode, bulb does not glow. Why is that? What's the reason for that? Right? Let's learn. In this instance, as you can see, bulb lights up only when the diode is kept in a specific way. What is that specific way? Can you remember? I told you in the first instance, I kept the positive terminal of the diode to the positive side of the battery. Negative terminal of the diode to the negative side of the battery. Accordingly, we can say that the current flows through a diode only in one direction. Right. The main function of a diode is to let the current flow in one direction only. We can do another simple activity to understand that. Here, this is a battery. This is the positive terminal. This is the negative terminal. This is a bulb. I am going to keep the diode between A and B. At first, I am going to keep the positive side of the diode to the positive side of the battery, negative side of the diode to the negative side. Now you can see bulb is glowing. Bulb is glowing. Bulb is glowing means current passes through the diode. Now I am going to change the terminals of the diode like this: positive to negative, negative to positive. Does the bulb glow? No. Bulb does not glow. Why is that? Bulb does not glow means current does not pass through the circuit. Through this activity also, you can realize that diode is an electronic device that allows the electricity to flow only in one direction. Right. What is the exact direction of current flow? We learned that diode allows the electricity to flow in one direction. But what is the direction? Here, the picture gives you a good idea. This is the positive side. It is black in color. Negative side, silver or white in color band is there. Current flows from positive side to the negative side. That means in a diode, the current flows from the positive side or positive terminal of the diode to the negative terminal of the diode. Keep in mind, diode is an electronic device which allows the electricity to flow only in one direction, and also the direction is positive side to the negative side. Current does not flow from negative to positive. Right. Shall we do another activity to find out the function of diode and how do we connect the diode to a circuit in proper way? Right. As you can see, in this activity, I am going to use a battery. You can remember a switch, connecting wires, two bulbs and diodes. My dear children, please draw your attention. How can I connect these appliances in the circuit? Here, positive terminal of the battery is connected to the positive side of the diode. Similarly, negative terminal of the battery is connected to the negative terminal of the diode. Let's do this activity. Here I have connected bulbs, two bulbs here, a diode here, negative terminal of the diode to the negative side of the battery. I am going to connect to the negative side of the battery and positive terminal of the diode to the positive side of the battery. Now I am going to switch on. As you can see, bulbs are glowing. Why is that? Current is flowing through the circuit. When we connect the negative side to the negative side of the diode, positive side to the positive side of the diode. Then I am going to change the terminals of the dry cell. Let's change the terminal and observe what will happen. First unclip, change the terminals, again I clip. Now I am going to switch on the switch. Bulb does not light up. You can see. Why is that? That means, my dear children, when changing the terminals of the battery, the terminals of the diode also changes. As a result, current does not flow through the circuit. That is why we couldn't observe the glowing of bulbs. From this simple activity, you have to understand that if we want to connect a diode to a circuit, always or definitely we must connect the positive terminal of the dry cell to the positive side of the diode and also negative terminal of the dry cell to the negative terminal of the diode. Today you studied how to connect a diode to a circuit and what is the specialty in a diode. If I ask this question again, what is the special function in a diode? Diode allows the electricity to flow only in one direction, that is from positive terminal to negative terminal. Alright, we studied that how to connect diodes to a circuit in proper way. In this instance, as shown in this diagram, positive to positive, negative to negative bulbs are glowing. But when changing the terminals of the battery, negative to positive of the diode, positive of the battery to the negative of the diode, in such instance, we could not light up the bulb. We could not light up the bulb. Here, then we can move to the next lesson, that is light emitting diodes or LEDs. Have you seen a small bulb lighting up in radios and televisions? What's your answer? Yes, you might have seen. Are they really bulbs? No, they are not bulbs. They are called as LEDs or light emitting diodes. As you can see, there are different types of LEDs that emit different colors of light. Right. This diagram shows you a picture of LED. You know, my dear children, LED consists of a long terminal and a short terminal. Long terminal is the positive terminal, short terminal is the negative terminal of the LED. Do you know the symbol of LED? Can you remember? We studied in the previous program. Symbol of LED. In the symbol of LED, two arrows are used instead of the diode. In the diode, no arrows are available. Here, positive terminal, negative terminal. Let's do a simple activity to study about LED. Right. I am going to arrange the circuit as earlier. This is the dry cell or the battery bulb, positive, negative of the dry cell. I am going to keep between A and B an LED. It glows. It glows. Now I am going to change the terminals of the LED. It doesn't glow. We can do another simple activity as shown in this picture here. Instead of the diode, I am going to represent an LED. You can see that. It is glowing. Now I am going to change the terminals again. Change the terminals of LED. It doesn't glow. Right. Through these simple activities, you can realize that LED is also behaves just like a normal diode. It is also called as light emitting diode. Why is that? Though it is a diode, though it is behaved like a diode, only difference is LEDs emit light when current passes through the circuit. Right. LED illuminates only at one occasion. LED is also a type of a diode. As I told you earlier, you can further study about this by focusing your attention. It emits light when there is a small current passing through it. Therefore, how did we call that? It is named as a light emitting diode, as it emits light when flowing current through it. Right. Let's move to the third electrical device that we are going to study today. What is that? That is called as a resistor. Have you ever heard about resistor? As you can see, the picture shows you some examples for resistors that we use in our day-to-day activities. I also brought several resistors here. You can see this is a picture of a real resistor. Not a picture, this is a real resistor. Right. This is another resistor. This is also another real resistor. Right. Let's do a simple activity to find out what are resistors and the function of resistors. Right. First of all, I am going to keep a good conductor between A and B. In this circuit, I am going to keep a good conductor. I am going to ask you a question. Can you remember what are conductors? Can you remember what are insulators? In the previous program, you studied the difference between conductors and insulators. Substances or material that conducts electricity are called as conductors. You can remember we studied different types of examples for conductors: copper, aluminium, iron, magnesium, mercury, silver, and also water. A good example for conductor. Today I brought another good conductor. Can you identify this conductor? What is this, my dear children? This is called as copper. So, first of all, I am going to keep this good conductor, copper, between A and B in this circuit. The battery is there. I have used 2 dry cells battery, bulb, connecting wires, and I am going to keep the conductor. What can you observe? The bulb is glowing with a higher brightness. That is because of this good conductor. Current passes from the battery through connecting wires, through the conductor copper, through the whole circuit. Now, I am going to remove the conductor and I am going to keep a resistor between A and B. But keep in mind, before moving to that activity, when keeping a good conductor between A and B, as you watched, bulb glows with a higher brightness. Bulb glows with a higher brightness. Now, I am going to keep a resistor between A and B. As shown in this picture, I am going to arrange the circuit and keep a resistor between A and B. This is a resistor. I am going to connect 2 ends of the resistor to the 2 ends of the dry cell. Here you can observe the lesser brightness. When using a resistor, brightness of the bulb decreases. Right. I can connect this resistor between the another circuit. Here you can observe, you can watch the difference here. When connecting a resistor between A and B, the brightness of the bulb reduces. Right. So, bulb glows with a lower brightness. through this simple activity, what did you understand? Tell me. When connecting a conductor between A and B, bulb glows with a higher brightness. Why is that? Conductors are the materials that conduct electricity well. Then, when keeping a resistor between A and B, bulb glows with a lower brightness. From that, what can you understand? Resistors reduce the amount of current that flows through the circuit. So, we can understand that resistance or resistors are the materials that control the amount of current passes through the circuit. So, we can say the barrier to the flow of electric current or the obstacle to the flow of electric current as electrical resistance. The unit used to measure the resistance is ohms. You all know that if we want to measure something, there should be a particular unit. We measure the length using meters. Similarly, we measure the mass using kilograms. Likewise, the unit used to measure the electrical resistance is ohms. We use this symbol for the ohm, and also we must remember the reason for using ohms, because George Simon Ohm is the scientist who greatly contributed on these activities. As a respect for him, we use the symbol ohm and the unit ohm to measure the electrical resistance. Right. Then we can conclude that about resistors, the materials that produces a resistance are called as resistors. I think you have a little doubt about the resistance and the resistors. What's the difference between resistance and resistors? Resistance means the barrier or the obstacle produced against the flow of current. What is that? The barrier or the obstacle produces against the flow of current. That is the resistance. So then what is resistor? Resistor means the material or the object that produces a resistance. Right, my dear children. I hope you have studied well. Let's focus our attention on the symbol of a resistor. As I told you earlier, as I shown you, this is a real resistor. This is the resistor. You can remember in the previous lesson we learned about symbols. Symbols are very important to prepare circuit diagrams. Right. Then, this is the symbol that we use as the symbol of resistor. There are some other symbols also. You will learn these things in next grades. For your grade, for grade 6 level, this is the symbol we used as resistor. Right. My dear children, there are different types of resistors. with different resistance values. I told you earlier, resistance is measured by ohms. There are resistors with 5 ohm, 6 ohm, 10 ohm, likewise. So, I am going to show you the difference of resistors with different resistance values. Here, I brought a resistor with 5 ohm resistance and another resistor with 10 ohm resistor. This has 5 ohm resistance. This has 10 ohm resistance. Let's connect both the resistors to the circuit and find out the difference here. Right. As you can see in this diagram, first of all, I am going to connect 5 ohm resistor to the circuit. As you can see, when connecting 5 ohms resistor to the circuit, bulb glows with a certain brightness. Right. Now, I remove the 5 ohm resistor and connect the 10 ohm resistor. Does the bulb glow? Yes, I think you can't see, but bulb is glowing with a very little brightness. Right. That means you can understand that when the resistance increases, it obstacles the flow of current. It causes a barrier for the flow of current, or it controls the flow of current. Right. We can do the same activity again. Bulb glows with the 5 ohm resistor with a little brightness, but 10 ohm resistor bulb glows with a very little brightness. It is invisible, right? Because resistance is very high. Through these simple activities, you could understand the effect of resistance on circuits and also how to differentiate the resistance. You can understand that the flow of current decreases with the increase of resistance. Flow of current decreases with the increase of resistance. When the resistance is low, flow of current is high. Resistance is high, flow of current is low. Right. Now, let's focus our attention on different types of resistors. I showed you only few resistors. They are called as permanent resistors because their resistance value cannot be changed. It is a permanent fixed value. So, this is a diagram of permanent resistor as I shown you earlier. A permanent resistor. There are color bands also, as you can see in this picture. Permanent resistors contain color bands. Right. This is an example for a variable resistor. What does that mean? The resistance value can change as required. For example, draw your attention about the regulators in the ceiling fan or stand fan. So we can change the speed of the fan by controlling the amount of current that flows through the circuit. So volume controllers, those are examples for variable resistors. Third type of resistor, we call it as light dependent resistor. This is the picture of light dependent resistor. I am going to show you a real example for light dependent resistor. This is a real example for a light dependent resistor. Why do we call this as a light dependent resistor? My dear children, this is a resistor in which the resistance depend on the amount of light falling on it. We can learn more details about the light dependent resistor in coming lessons. Right. Instances of using resistors. Before moving to that, I would like to ask you a question. Tell me, what is resistance? What are resistors? Resistance is the barrier for the flow of current. Resistors are the materials that produces a resistance. So, do we want to use these resistors in our day-to-day life? Yes. Why not? These are some examples that we use resistors in our day-to-day life. In fan regulators, to control the speed of fans, I told you earlier. In brightness controlling bulbs, you might have seen sometimes we use bulbs where the brightness can be reduced or increased. The brightness change in bulbs contains resistors. In the volume controllers of televisions and radios, do you know, my dear children, sometimes when watching TV or when listening to the radio, you increase the volume. Sometimes you decrease the volume. What happens here? When you press the volume increasing button, resistance decreases. When you press the volume decreasing button, resistance increases. When the resistance increases, current reduces, so volume reduces. Right. Let's move to the next lesson, light depending resistors, or we call this as LDR. What are called as light dependent resistors? Let's learn more information. You watched LDR, but we can study more information about LDR. Resistors in which the resistance depend on the amount of light falling on it are called as light dependent resistors or LDR. Right. What are called as LDR or what are called as light dependent resistors? Resistors in which the resistance depend on the amount of light falling on it. Picture of the LDR is given. Symbol of the LDR is also given in this picture. Here, can you see a difference between the previously learned symbol of a resistor and symbol of a LDR? Yes, you can see. If we remove this circle and these two arrows, this is the symbol of a resistor. Symbol of a normal resistor. But here LDR means light depending resistors. That is why we use two arrows to represent that falling of light on the resistor, then its resistance vary or depend according to the light intensity that falls on the resistor. You will never forget the symbol. It's very easy, right? My dear children, you studied about diodes, LEDs, resistors. Then shall we do a simple activity to find out the function of a LDR? How does it behave? Right? Let's do it. First of all, we have to arrange the circuit as shown in this picture. What do we need? A dry cell, a switch, a galvanometer. Right. This is the battery. I used here two dry cells. I connect the connecting wires. This is the connecting wires, LDR, switch, galvanometer. Now I am going to complete the circuit by using the switch. You can see a deflection. You can see a deflection in the galvanometer. Now I am going to cover this LDR because you can see a deflection, current passes through the circuit. You can remember, deflection of the galvanometer means current passes through the circuit. Here, when I am going to connect, it deflects right side, galvanometer deflects. Because light falls on this. Now I am going to cover the LDR using my finger and switch on. You can see the difference. It deflects only to very small amount. Removing the finger, it deflects more. Covering the finger. Now you can understand the difference. When I cover the LDR using the finger, light does not fall on it. So very small current is passing through the circuit. When I take the finger away, more current passes through the circuit because when light falls on the LDR, its resistance decreases. Through this simple activity, you can realize that LDR is an electronic device in which the resistance depends on the amount of light falling on it. Amount of light falling on it. So we can summarize that. When light falls on the LDR, its resistance decreases. When light does not fall on the LDR, or when there is dark, its resistance increases. I am going to show you again that activity. Light falls on that, more current passes because resistance decreases. Now I am going to cover the LDR using the finger. Only a little current passes through that. That is because of increase in the resistance of the LDR. Right. So again, we can go to the slide. When the light falls on the LDR, resistance of it reduces, and when less light falls on the LDR or when there is dark, the resistance increases. Light dependent resistors, LDR, are the resistors that change the resistance based on the amount of light falling on it. What is that? LDR or light dependent resistors are the resistors that change the resistance according to the amount of light falling on it. Now, we have studied lot of electronic devices. Again, what did you study today? Diode, LED or light emitting diode, resistors, and also just now we studied about LDR. I am going to ask you some questions. Right. Draw the correct symbols. Appliances are there. Diodes, LED, resistors, LDR. You can take a pen and draw the symbols and identify the pictures. Diode. Picture of diode. Symbol of the diode. Picture of the LED. Symbol of the LED. Picture of the resistor. Symbol of the resistor. Picture of the LDR. Symbol of the LDR. Right. You can focus your attention and keep in mind the symbols of appliances and the pictures of these appliances. Let's move to the final part of our unit, conservation of electricity and prevention of accidents. Why is it essential to conserve electricity? We learned that today we use electricity for most of the day-to-day activities. The consumption of electricity is increasing day by day. At present, the generated electricity is not sufficient. Therefore, there is an energy crisis in the world. Right. What are the ways of conserving electricity? Use efficient bulbs, switch off the appliances when they are not in use, do not increase the sound of televisions and radios unnecessarily, use televisions and computers with LCD and LED screens, they minimize the consumption of electricity, use refrigerators which minimize the consumption of electricity, by ironing many clothes at once. Then you have to understand that how to prevent the accidents caused by electricity. Electricity is sometimes a good servant for us, my dear children, but sometimes a bad lord too. Why do I say so? There may be a lot of accidents if we use electricity careless manner. Careless use of electricity may cause damages to the property, serious accidents, and sometimes even death. There are some examples for accidents. Switch off the power supply when repairing. Switch off the plug before inserting the plug tops. Do not cut trees on electric cables. Do not send kites near the electric cables. Do not fix antennas near the electric cables. Do not handle ladders near electric cables. Do not touch broken electric cables. Do not try to get electricity directly from electric cables. Do not fix many appliances to same socket. Apart from the above facts, we must pay attention into these facts well. Keep electric wires and extension cords out of children. Do not let children to go near electric sockets. Unplug multi-sockets when not in use. Do not touch electric circuits and appliances with wet hand. When using electric irons or other appliances, wear rubber slippers or stand on rubber doormat. If you notice some unusual nature of an electric appliance or a circuit, please call your electricity service provider immediately. Disconnect the main switch in your house during flood. Do not let children to use electric appliances without the inspection of an adult. This is the end of our program. I am going to ask you some questions. Select the correct answer from the brackets. Is an electrical appliance that allows the electricity to flow only in one direction? What's the answer? Diode. Emits light when current passes through them. What is that? LEDs. The barrier for the flow of current is known as, what is the answer? Resistor or resistance? The barrier? Resistance. Last question. When light falls on LDR, the resistance of it, what happens? When light falls on LDR, the resistance of it increases or decreases? Decreases. This is the final part of our program. I am going to summarize things that we learned so far. There are many electronic appliances used in circuits: diodes, light emitting diodes, resistors, light depending resistors. We learned those things. Alright children, we learned everything relevant to the Unit 8 Electricity for a Comfortable Life. I hope you enjoyed the lesson. So please refer to the textbook and get the support from your class teacher, answer question papers, and also you can watch same programs through channel NIE YouTube. Have a nice day.